ahead and record. Alright, so let's move forward and let's take a look at programming assignment 4. So this posted yesterday afternoon. And PA4 is a lot of fun. This is a project that you can sink your teeth into and I think have a good time with, hopefully. So you're going to write a computer version of the game that I learned as dots. Some people call this game boxes, but I called it dots when I first learned it. So you may have played this before. Basic setup, right? So you have two people and you draw a playing field, and your playing field starts with a 2D array of dots. So I'll just do a 5 by 5, but you know, depending on how long you want the game to go, you can do an 8 by 8 or whatever. Alright, and you take turns. So you have two people, each person takes a turn, and when it's your turn, you get to connect two dots. Okay, now you can connect either horizontally or vertically, you can't connect diagonally, and your goal is to create boxes. So I might go first and I might draw a line right there, and my friend might draw a line there, and I might draw a line here, and they might go there, and I might go somewhere totally out in the blue like this, and they might go there. And you keep doing this, and maybe my friend goes right there. Okay, now I realize that there is a place where if I draw a line, I can complete a box. Actually, if I draw this line or that line, I'll be set. Okay? So, if you draw a line that completes a box, you get to put your initial in the box and go again. Okay, well, I'm going to draw this line. Hey, I just completed a box. I put my initial in it. I get to go again. I'm going to draw this line, put my initial in the box. I get to go again. So I'll draw a line right there. Well, that wasn't a really smart move to make, because now my friend can draw a line and put their initial in. So my imaginary friend today is Larry. So Larry puts that down, and he'll draw a line over here. And you just keep doing this. And when all the boxes have been made, whoever has the most initials is the winner. Okay? So it's, you know, pretty exciting game. It's up there with, you know, Skyrim and all these other adventure games. So that's dots. Okay? Now you're not making a computer program that plays dots for you. All you're doing is creating a platform where two people can play this game without using paper and pencil. So presumably they'll be sharing the mouse, passing it back and forth, and using the computer to represent the playing field and to choose which lines to draw. So let me give you a an example of what this looks like in action. Alright, so here's my playing field. And this is a 9 by 9 array of dots, so 8 boxes by 8 boxes. And I'll go ahead and put my name in here, and I'll have Larry's name down here, and I'm going to hit the start button. And when I say start, it tells me Nick's score is 0, Larry's is 0, and the current player's move is Nick. Okay, I can point to a non-drawn line and click, and my program will draw a line there. And now it says it's Larry's turn, so Larry might go here, and I might go here. And there's no distinction as to, you know, whose line belongs to who. There's no ownership until somebody completes a box. So at this point, it's Larry's turn. Maybe Larry notices there's a box here, clicks here. There's an L for Larry. His score goes up to 1, and he gets to go again. So he might hit this one. Now he's got 2, and now he can hit this one. And this one, he's just got 4 points now. Okay, and his next box might be right here. Well, now I can go over here and get my initial on, so I'm on the scoreboard, and I might go over here. And you can, you know, put your lines anywhere that you want. Now, if a line's already taken and somebody tries to take it, it'll tell you that spot's already taken, and the person gets to go again. And that's basically the game. Okay. There's a restart option if you get tired of the current game. If somebody wants to give up, you can hit restart. Everything resets back to the beginning. Okay, no score, no lines. It's Nick's move again. And if you don't put names in the beginning and you try to start the game, it'll say, you know, enter a name for player 1. So this is Nick, and it'll say enter a name for player 2. And if that's Nancy, it'll say make their first initials different, right? So you can embellish this however you like. Whatever you want to do within the bounds of the assignment, okay? So there's a lot of wiggle room here for creativity. All right, so, and my code is printing out tons of debug messages. We'll look at these in a little bit. But let's go through the assignment, okay? And if there's questions along the way, please ask, okay? So you're writing a computer version of dots. I suggest working in Eclipse. Okay, Eclipse is what you're responsible for in this class. If you want to work on the command line, you can do that, but it's a lot of work to get all the swing classes to work correctly. It's a whole lot easier in Eclipse, and I want you to concentrate on implementing this code as opposed to, you know, the details of how do I write an action listener and where do the parentheses go and that kind of thing. So Eclipse is a good environment to work in. When you're done, your code should work as a set of standalone classes. So for example, I have, you know, 3 Java files, and if I compile them, I get some class files, and if I just say Java dots, it runs dots.class. That should execute my, my program. Okay, so we'll talk about submission in a little bit. Program allows 2 people to play dots on the computer. They take turns using the mouse to select lines to draw. The program handles drawing the lines, completing the boxes, adding initials, keeping track of whose turn it is, tracking the score, knowing when the game's over. And I may extend PA4 into PA5. It may be a variation on this. Haven't decided yet. I'll decide in the next week and a half. Okay. So there's a description of gameplay, which we already played through. So this is a group project. Okay, you can work in groups of up to 3 people. Okay, you can work with people from this section or the other section. That's fine. No more than 3 people in a group. Okay, that's the first thing. And my recommendation is don't use the group aspect to cut down the amount of work you have to do. If you feel like you're pretty good at writing Java code, but you really don't understand the GUI part of it, do not do this. Don't say, okay, you write the GUI, I'll write the back end. Okay? That's a bad strategy. It's a great strategy for the workplace. It's a bad strategy for school. So what I'd like you to do is for each of you to make this project your own, to write the whole thing from start to finish, to understand every aspect of it from start to finish. Okay, because you're responsible for all of this. You might have to use it for PA5, you're responsible for it on the exams. You'll be responsible for knowing this in future courses. So every person, regardless of who you're working with, should take this as a project they're doing entirely from start to finish by themselves. What I suggest using the group component for is a legal friend or 2 that you can talk to and go to for help and offer help to on this assignment. So if you're in a group with 2 other people, the 3 of you can look at each other's code, you can ask questions, you can help each other debug code, you can bounce ideas off of one another, you can make suggestions, and so on and so forth. You can share code. Okay? It's completely open within your group what you do. Okay, but that's still different from saying, I'm gonna, you know, write this method, and you write that method, and this other person will do this, right? And then you have no idea what these other people did. That's not a good strategy. So try to do the whole project from start to finish, right? But use your group members for help, okay? To kick ideas around, to look at code, to get ideas, and so on and so forth. Hopefully that makes sense. If not, let me know. All right, the other thing, since you're working in a group, is how to deal with submission. Okay, you're submitting through Git as usual. So ideally, only one person submits to Git, which simply means, yeah, you can have a Git repo, you can keep it posted on GitLab, just don't make me a reporter, okay? So you have to coordinate this among yourself and your group members, decide who is going to submit the actual code to be graded, and make really sure that that person has set me up as a reporter. And then, ideally, the other members should not give me reporter access. So what's going to happen when I grade this is I'm going to go out and I'm going to download all the repositories that I can, and I'm going to start grading them in whatever order I choose. It might be alphabetical, reverse alphabetical, who knows. If two people from your group submit different code, the first one that I encounter is the one that's going to be graded and the one that you'll all get a grade for. So either make sure only one of you has marked me as a reporter, or just make sure all your code is consistent. Make sure whatever version you decide to submit for the group is in everybody's repo. Okay? Hopefully that makes sense. The other thing is, make sure that in every Java file I find the full name of everybody in your group. Okay? Because I'll open up probably the main .java file, and I'll look to see who gets credit. And whoever's name is in there will get credit. So make sure your name is in there, whoever's submitting it. And don't put more than 3 names in there, because if you're working in a group bigger than 3 people, you're not going to get any credit. Okay, so it's 1, 2, or 3 person groups only. Alright, so what should your program do? Begin by drawing a grid of dots. Okay, your board should be 9 dots by 9 dots. That's an 8 by 8 set of boxes. Each box should be 50 by 50 pixels. Now you can make these variable inside your program. Don't hardwire 50 by 50, right? Just make something called box size and set it equal to 50. But when I run it, I want to see 81 dots on the board spaced 50 pixels apart. Okay. There should be some way for 2 people to enter their names in text fields, edit boxes, something. Okay. Don't set it up so that when I run your program, it asks me on the command line what my name is, and I have to type in my name and hit enter. Okay. Everything should happen through the graphical interface. Now, how you do that, it's up to you. Like I say, probably a text field is an easy way to do that, but some way to have players enter their names, and some sort of start button to begin the action. Okay. And then the game should show whose turn it is, right? Keep track of whose turn it is and display that in some way. You can do it by initial, you can color code it, you can use full names. It's up to you, okay? If I click the mouse inside the grid area, it should draw the closest line, unless that line's already taken, in which case it should say, you know, that line's already taken, try again, and let the person pick a different line. Anytime that drawing a line completes a box, the game should notice that, add the user's initial to the completed boxes, and then leave the current player's turn as their turn, right? Otherwise, play switches over to the other player. And you know, sometimes your board may look like this, and it's my turn. I'm going to draw 1 line, but I'm going to get 2 boxes for it. Okay? The game has to be able to pick that up too. Alright, show each player's score somewhere in a graphical element, right? A JLabel, text box, something. And then the game should notice when all the boxes are filled, and at that point it should report who won or say that there was a tie. And there should be a restart button to let you play the game again, either when the game's over, or if you just want to start over again partway through. Okay, everybody got the basic idea of you know, what the game should look like when you play it? Cool, awesome, thank you. Alright, so suggestions for setting this up. So I coded this up myself to see what would it be involved in making this work. And there are definitely a lot of ways you can go about this. And if you feel like you have a way in mind that you want to implement this and you want to try that out, go for it. Okay, you're not required to do what I'm going to describe. But what I'm going to describe next is a way to code this that I think makes a lot of sense and keeps things from getting too complicated, and also creates a framework in which it's relatively easy to expand and add things and modify things. Okay, so I think this is a nice way to approach it, but you know, you can approach it however you choose. So some general suggestions. Okay, first thing, this is not your usual procedural program. It's not a big while loop. It's not a bunch of if statements sitting inside a for loop. Okay, it's all event driven. So you get to do some initialization in the beginning, and then nothing happens until a mouse is clicked. And when somebody clicks a mouse, basically you can have one method that gets called. And that method is called with the X and Y coordinates of the mouse, and that's really all you've got. And inside that method, you've got to do whatever has to happen in response to the mouse click. Okay, so you think about this in terms of not, you know, here's a for loop, while there's still boxes left, let's do the following, right? Think of it from the viewpoint of interrupts. Okay, I'm going to write a function which will be called when the mouse gets clicked. It'll tell me the XY coordinates of the mouse, and based on that, I have to make some stuff happen. And when you're done making whatever happens happen, you have to return. You have to get out of your function that was called and let the system go back to waiting for more events. You cannot do an infinite loop in your mouse handler. It will mess up the Java virtual machine, right? Other things won't work correctly. Okay, the other thing to remember is we don't get to paint by just saying paint. Somebody clicks the mouse and you decide, oh, the top of this box should have a line on it. You can't just say draw a line. All you can do is set things up so that paint will draw a line, and then you get to call repaint, and paint will call paint, and paint will do the actual painting. So it's a lot of, you know, here's what I want to have happen eventually, but setting things up so that somewhere down the road something will happen. Alright, so along those lines, really important to ask questions. Okay? For most of us, this is a different way of programming. It's not going to make sense the first few times through. It'll start to come into focus the more you work on this, but it's going to take some working on it, getting confused, asking questions, thinking about answers, iterating on this a few times. Okay, it's a really worthwhile process because this is a segue into a totally different mindset of programming, and it's a mindset that works really well with objects. Okay, so the effort will be well worth it, but ask questions. Okay, I will say that my email availability is beginning to drop. Okay, I'm getting hit with more and more questions from these classes and from my 250 class. More and more I'm asking people to come to me in office hours and screen share and work through issues on code there and so on and so forth. I will also say that office hours are starting to get more crowded. Okay, so I have 8 hours a week that I'm available through Zoom outside of class. Those are starting to fill up, and they'll fill up more as we get closer to final exams. So good reasons to be working on this sooner rather than later, so that you can come and ask questions sooner rather than later. If you wait till the day before, or you know, the way it was yesterday, the night before this is due, there's only so much help that I can give you through email. Alright, so here's the way that I thought of the board. Okay, I built everything around a class named box. And a box is basically, you know, one of these potential boxes in your playing area. So this I'm thinking of as a box. And the board I'm thinking of is just a 2D array of these types of objects. So we have to talk about how to make 2D arrays, but it's not too bad to do. We'll probably talk about that tomorrow. Just made myself a note. But here's my box class. Okay, so what do we need to know about a box? We mostly want to know, is there a line on the top, on the bottom, on the left, and the right? So you can make a set of booleans, top, bottom, left, right. And when a line gets drawn on the left side of this box object's left variable will be set to true. And by default, all of these will get set to false when you construct the box, right? And so if I have a two-dimensional array of objects of type box, right? So box bracket 8. Let me do it like, we'll have to talk about this. So box bracket bracket board. All right, that's a two-dimensional array of boxes. And so board, you have to construct it and so on. But board bracket row bracket column is a box. It's one of these things. And I can say board bracket row bracket column dot left and see if the left line of that box has been drawn or not. Okay, the other thing that's nice to have in this box object is something like who, which basically says whose initial is in this box. And you can initialize it to maybe an empty space to say nobody owns it, and then if somebody marks the box as theirs, you can change this to their initial. Or a number to say the player number, or a name, or whatever you choose to do, okay? But something that captures this information per box in the board area. Is there a line on the top, bottom, left, right, and whose initial is in there? That seems to be a good starting point for coding this, okay? So I used a box class, booleans for top, bottom, left, right, and some sort of mechanism for indicating which player owns that box. All right, next suggestion, modularize. I've been saying this since 2.24, but it's more emphatic here, okay? There's a lot of code involved in this. It's going to be at least a few hundred lines of code. You really don't want to be rewriting the same code multiple places. Partially because, you know, that just takes a lot of typing and it's a lot of code to write. Partly because, you know, you may find out that you've done something wrong and you have to go back and you have to change every place that you did it. So if you've got some set of instructions that you're going to use again and again and again, put them in a function, okay, a method. So here's some suggestions. Make a method for initializing the game board. Why do you do that? Well, because when you first construct the game board, you can just say initialize game board. And when the person hits the restart button, you can say initialize game board. And when the game ends, if you automatically start a new game, you can just say initialize the game board, right? And that can handle all the stuff. That can handle, you know, resetting these booleans to be false and setting the who field to be empty and resetting the score to be 0 and 0 and so on and so forth. Make a method for updating the score. Right? How do you update the score? Well, if this is a two-dimensional array of boxes, I can make a pair of nested loops. For r equals 0 to, you know, however many boxes I have, -1. For c equals 0 to boxes -1. If board bracket r bracket c dot character, sorry, dot who equals, you know, first player's initial, increment score 1. If it's equal to second player's initial, increment score 2. Do that whole loop. And then if you're using, say, a JLabel to display the score, call JLabel.setText with the new score. Now you put all that in a method called updateScore, and now anytime that the score might change, you just call updateScore. All right? And in your initialize the game board, what do? Set score 1 equals score 2 equals 0, and then call updateScore. So start thinking in terms of, you know, what are the major functions I'm going to want to do, and lean towards putting each of those functions in its own method. And when you're writing more methods, think about how can I reuse these methods that I've already written. Okay, make a method to see if the game is over. How do you do that? Update the score and see if the sum of the scores is equal to the number of boxes you have. So if my board size is, in a variable called board size, and that's 8, if score 1 plus score 2 equals board size times board size, the game's over. Well, go ahead and bundle that in a function. It might only be 2 or 3 lines of code, assuming you're calling this to update the score. But put it in a function, and logically, I can just say if parentheses game over paren, then, do whatever. Set a flag to disable the mouse or whatever you want to do. So part of the art of programming is sort of figuring out where these layers of compartmentalization make the most sense. So at some level, this whole thing has a single function, which is to play the game of dots. And you could say, well, it's all doing one thing, so I'm just going to make one method called play the game. Okay, and that makes some sense, in a reductionist kind of way. At the other extreme is, I want to know if the top of the box has been set. So I could make a method called check top of box, and I could make a method called check bottom of box, and a method called check left of box. That's probably too fine-grained, okay? Because really, I can check the top, bottom, left, and right, in just a single if statement each. If I want to know if all of those are set, I can say if top and bottom and left and right? So throwing each of those into a separate method, probably overkill, okay? But trying to figure out where that line is, that's part of what you're developing as your own personal style and expertise as programmers. So for me, this was one really useful method, a method which checks for an XY click to see if it's legal, and if it is, updates the array of boxes, and then updates whose turn it is. And those things all kind of went together, and I was never going to adjust a player's turn unless a click had just been made, and I was never going to worry about a move being legal until a click had just been made, so putting all of these in the same method made a lot of sense, right? And you can put some of this, like the legal checking, in another method that you call inside here, right? But the idea is, think about your main loop. What do you do? It's not a loop. Think about your main response, right? Your mouse handler. What do you want to do? Basically, draw a line, move on. Okay, so think about these methods. All right, so mouse clicks. What happens when the mouse gets clicked? You get the XY coordinates in a piece of code, figure out what box you're in, figure out where you are in that box, which side are you closest to, and then act accordingly, which for us means drawing a line or discovering that the line has already been drawn and reporting an error to the user. Okay, if you're drawing a line, then you want to check to see if a new box has been completed. Okay, and if the box has been completed, you want to put the person's initial in that box and leave it as that player's turn. Okay, so an important thing to keep in mind here, these boxes share walls. So if this box is box R comma C, and I'm thinking row goes down and column goes across, if this is R comma C, this box is R comma C minus 1. This box is R C plus 1. This is R minus 1C, and this is R plus 1C. So here's the thing, if you click the mouse and you decide you're in box RC, right, so I could do something like box B equals board RC. And if I decide that you clicked on the left side of the box, I could say if not, b dot left, right? So you click close to the left side of this, and this Boolean is false, which means there's not a line there already. What do I want to do? B dot left equals true. You've also got to go through and adjust the box to your left. If I'm in this box, if I just clicked right here, I'm going to set this line to be true. You've also got to go to the box on your left and set its right line to be true. So something like board bracket r bracket c minus 1 dot right equals true. Okay, because most of these edges are shared by one adjacent box. But you got to be careful, because if I was on the leftmost column and c was equal to 0, if I try to do board r c minus 1, I'm going to get an exception. So before you do this, make sure that c minus 1 is not negative. Or if you're on the right, make sure c plus 1 is not bigger than or equal to the number of boxes. So check your bounds. Don't just do a try-catch block. Check your bounds explicitly. Okay, but this is basically all there is to recording a mouse click, right? Decide which side you are closest to, which we'll still talk about. Set your Boolean, set the corresponding Boolean in the neighbor, and you're done. You've recorded that mouse click event. All right. After you've recorded that mouse click event, what do? Call something that updates the status of the board. So what does that mean? Well, go through your whole two-dimensional array, and for each box, check to see if top, bottom, left, and right are all true. And if they are, and if nobody claims that box, that means the person just completed a box. So set this to whoever that player's initial is, and record the fact in some kind of Boolean that this person completed a box, so that they get to go again. If you go through all the boxes and all the completed ones already had initials in them, then this person did not complete a box, and so now you switch to the other player's turn. And the question of whose turn it is simply affects whose initial you're putting in the box that gets completed. And when I'm doing this, I don't have to think about scores. I don't have to add 1 to the person's score because I put an n in here. I could, but I don't have to, because I've got this function called update score. And after I'm done with all of this, I'm just going to call update score, and it's going to go through and count how many n's, how many l's. So try to be kind of single-minded in your choice of what your methods do, right? Right now, this block of code is just going through and looking to see if there's a new box completed. Okay, now I'm going to run through a set of code that's going to go through and count up how many boxes belong to each player. Now I'm going to run some code to see if the scores add up to the number of boxes to know that the game's over, and so on. All right. Most of what we are doing in this program has nothing to do with graphical elements. Everything I've described so far can be done without any visual elements, other than you need a way to click the mouse. But you're getting a function call, you're being passed XY coordinates. All of this business of going through and finding out which edge and updating that and counting squares and so on, nothing to do with the GUI. Okay? The GUI is primarily, something to guide the person when they're trying to click near a pair of dots, and a way to display the board. The display of the board is done by a paint method. All of your mouse handling code is really just updating this array in memory. And the paint method simply reads from this array and creates a visual display based on it. But they're fundamentally distinct tasks. Okay, and this is the other part where this can get more confusing than it needs to be. If you start thinking about updating the GUI while you're doing things like this, you're going to make your life a lot more complex. So think about separate tasks. First, you're going to update the memory, update the data structure, and then you're going to call paint And Paint's going to read that updated structure and draw the playing field. And Paint's job is pretty straightforward. A pair of nested loops, R goes from 0 to 7, C goes from 0 to 7, right? Pick out the box at that given row and column, and then check to see if the top, bottom, left, and right are true. If the top is true, call draw line for whatever the coordinates are for the top edge of that box. If bottom is true, then call draw line again for whatever the coordinates are for the bottom of that box, and so on. And then if the who field says that somebody's initial is there, call drawString with this one character to draw that initial in the middle of the box. Alright, so we have to talk about coordinate mapping, and that's also part of tomorrow's topic. So if I know that I'm in box 2, 3, right, how do I figure out what the x and y coordinates are for this corner, that corner, that corner, and that corner, so that I can say, you know, draw a line between here? So we'll go through that, okay, and that's pretty straightforward, but lots of room for confusion. So we'll talk about that tomorrow. But Paint basically just reads the structure from memory, draws lines, draws initials, and then, you know, displays the score in whatever way. So loop through the 2D array for each box, find the coordinates of each corner, draw the appropriate line, and then draw the initial near the middle using drawString. Okay, and if you do this methodically, it is a lot of fun. Okay, once you get the basic framework set up, it starts getting to be easier, right? The more features you add, the further you get into the gameplay, the easier it actually is to write the code. Because you're going to have more of the pieces in place, and if you decide, you know, I want to highlight the last line in red, that's actually pretty easy to add. Okay, so work methodically, give yourself a lot of time to work on this, right? And be open to possibly deciding once or twice or more that you want to go back and rework things. Because as you start writing this, you may decide, you know, oh, you know, I really should have thought of this in terms of lines instead of dots, you know, or dots instead of lines, or something like that. And you may want to go back and start from the beginning again, okay? Alright, let's talk about grading. So, 100 points total. If I can download it and compile it, 15 points. If the program runs and it draws a field of dots and shows an initial score of 0, 0, 15 points. If there's a way on the playing field to enter names so that the board will use those players' initials, that's another 5 points. And if the game does pretty much anything when I click the mouse, you know, if it draws a line somewhere, that's another 15 points. So you get 50 points for a pretty bare minimum, okay? So the other 50 points are about playing dots, right? So 20 points if it actually draws a line between the dots near where I clicked. Okay, so the move selection is working. An extra 5 if it notices illegal moves. So if I click outside the playing area, it should not just draw a line, you know, at some random spot. It should either give me a message or just do nothing. And if you try to take a line that's already been drawn, it should not, you know, just move on to the other player. It should let me know that line's been taken. So that's 5 points for illegal move handling. It should detect when a box is completed and draw the current player's initial in the middle. Okay, that's worth 10 points. It should keep track of whose turn it is and tell me at each point whose turn it is, including the idea that if you just completed a box, it still is your turn. So that's 5 points. Should report the score correctly at all times. That's 5 points. And some sort of button for restarting the game, either at the end or partway through the game. That's your final 5 points. Okay, I'm not giving points or taking away points for style this time. I'm seeing really good coding style in PA3. Keep it up. Okay, it hasn't become unimportant just because I'm not grading based on it now. but keep up the good coding style, consistent indenting, lots of commenting, especially if you're working in groups, right? Because part of group work is probably going to be, you know, comparing your code at some point, and you want to be able to explain your code to your classmate, you know, and say, well, this is the one we should submit for grading. You want to understand your code. And if we use this for PA5, you want to be able to go back and know what you did. This is also a really good project to put in your portfolio, right? It's graphical, it's really easy to see that it does something cool, right? And it's got a lot of parts and pieces, it's event driven, it's modern, right? This is a nice one to put in your Git portfolio, and when you're, you know, talking to someone in a job interview or wherever, you know, you can say, oh yeah, here's something I wrote for my Java class, you know, it does GUIs with swing, etc., etc. All right, so submission. Again, one submission per group, please. Otherwise, I'll randomly grade whichever one I come across first. Upload your .java files, GitLab repo name CSE223 dots. Okay, your main class is supposed to be called dots. Somewhere up here, I say that. Maybe I don't say that. I should say that. Well, dots shows up a lot in here. Yes, your main class containing your main method should be named dots. Okay, that was right there where it was. All right, so put all your .java files into a GitLab repo, right? Push them over to GitLab, make me a reporter. Make sure when you're in Eclipse that you only use the default package. Okay, if you don't use the default package, it will put a package statement in, and unless I reproduce your directory structure, I won't be able to run your code. Okay, every time that we've used Eclipse, and every time that we use Eclipse, other than when we talk about packages next week or the week after, I've been using the default package. So use the default package. Don't know if there's documentation on Canvas, but just go to Eclipse, and there's video footage from last week where I did this, and I suggested go to download packages and come over here and pick up the Photon package, and then do Eclipse IDE for Java developers, whichever platform you like. All right, so use the default package only, right? If you go to Stack Overflow, people will say never use the default package. Use the default, okay? And make sure that the Java files you submit, if you just compile them and run them by saying Java dots, make sure that works. So either test that on your Unix system or find someone with a Unix system to make sure that that's how it's set up. If you want, you can try testing this on the Linux server itself. It will not run, but it should give you an error message like this that tells you that it's working correctly. Okay. Or if you want, at least 48 hours before the deadline, you can push your repo and ask me to see if it's set up correctly. Okay. Even if it's not complete, right, I can at least look at it and say, yes, this is a form that I can download, compile, and test. Okay. And I won't grade it ahead of time, but I'll just tell you, you know, if I can get to the files and if they're in the right structure. All right, any questions about that? There's a lot there, I know. Hopefully it's more detail is better. So if I try to run this on the Linux server, it's not going to work. Right, it's going to tell me it's a headless environment, right? It doesn't have access to my keyboard and mouse because it's, you know, this is the Linux server. I'm talking to it through SSH. It's just sending characters back and forth. If you want to get a little crazy, you can do SSH-X, and that'll open up an X11 pathway that basically lets me run visual code on the Linux machine, but have it interact with my own laptop. Okay, this is kind of slow, but it works. It's a really old, very stable way to do graphics on remote machines. And if you have an X11 server on your own machine, if you have Linux, this works automatically. If you have an X11 server on your Windows machine or your Mac, this should work also. So that's the other way to test your code and make sure that it works from the command line. So you're going to be developing an Eclipse, but we'll talk about how to get your files out of Eclipse and get to just the bare source files. I'll talk about that this week also. All right. That's all we got for today. So we'll dig into more details tomorrow. We'll talk about how to deal with some of the graphics, the coordinate transformations, resolving mouse clicks, and so on and so forth. All right. Have a good afternoon. I will see you next time.